Welcome to part 2 of the Fundamental Theorem of Calculus. I have example number 4 on here. To evaluate these integrals, I have the integral from 0 to 1 of 3 plus 1/2 times u to the 4th minus 2/3 times u to the 9th du. So this would be, once we evaluate this, to be 3u plus 1/10 times u to the 5th minus, this would be 1/15 u to the 10th. And we want to evaluate this between 0 and 1. So this would be 3 times 1 plus 1/10 times 1 to the 5th minus 1/15 times 1 to the 10th. And that would put in minus the integrated portion we have here at 0, but that would just give 0 again. So we can evaluate this as just being 3 plus 1/10 minus 1/15. And that gives us 3.033 repeating as a fraction that's 91/30ths. In part B, the integral from pi over 6 to pi of sine of theta d theta. This is negative cosine of theta. Evaluated between pi over 6 and pi. So negative cosine of pi plus cosine of pi over 6. This is 1 plus the square root of 3 divided by 2. For example number 5, what's wrong with this? The integral from pi over 3 to pi of 2 times the secant of theta times d theta. Sorry, 2 times the secant of theta times the tangent of theta d theta is equal to 2 times the secant of theta, evaluated between pi over 3 and pi, and we have that being equal to -6. So for us to see this, let me pull up a graphing calculator for us to see what on earth is going on here. So doing so, as I open this up for us, this would be, as we put in to our function here, 2 times the secant of x times the tangent of x. We could see something going on in these particular graphs, right? We have between pi over 3 and pi, well, the function does not exist at pi over 2, as we could see on this. Since we have up to pi being right here, we have 0 over here, pi over here. Pi over 3 would be someplace below this, but again, once we get to pi over 2, it ceases to exist. So that is not good. So what does that mean? This is not continuous. On that closed interval from pi to pi over 3. Excuse me, from pi over 3 to pi. From pi over 3 to pi. And the reason for that is because we have an infinite discontinuity at x is equal to pi over 2. So this answer does not exist. And my last example, we want to find the derivative of this function g of x is equal to the integral from 2x to 7x of u squared minus 5 divided by u squared plus 5 du. So g of x would be equal to, we could break this apart with the value of 0. So this would be the integral from 2x to 0 of u squared minus 5 divided by u squared plus 5 du, plus the integral from 0 to 7x of u squared minus 5 divided by u squared plus 5 du. And we can flip the integration bounds by making this first integral here the negative of the integral from 0 to 2x of u squared minus 5 divided by u squared plus 5 du, plus the integral from 0 to 7x of u squared minus 5 divided by u squared plus 5 du. So based upon this, we could take the derivative, g prime of x, to be negative. This would be 2x squared minus 5 divided by 2x squared plus 5 times the derivative with respect to x of 2x, plus this will be 7x squared minus 5 divided by 7x squared plus 5 times the derivative with respect to x of 7x. So this just becomes negative 2 times 4x squared minus 5 divided by 4x squared plus 5 plus 7 times 49x squared minus 5 divided by 49x squared plus 5. Let me know if any of you have any questions or concerns. Thank you.